In this video, we are going to look at integration by parts. Look at this function. We are asked to evaluate integral x in x dx. Amen. I'm going to teach you how to use integration by parts. Let's write solution and do it together. Is that clear? Solution. Integral x in x dx. Amen. Okay. We now write the formula using integration by parts. Amen. Using integration by parts. Integral u dv is equals to u v minus integral v du. Okay, you know this function, we know very well that without one telling you, if you compare this and this, you know that your u is equals to x and your dv is equals to in x dx. But if we do it that way, we cannot have a solution. Is that clear? Since in mathematics, you know very well that multiplication is commutative. That is, if we assume that a times b, this is the same thing as b times a, is commutative. So, for that reason, we are going to apply commutative law here to integrate this function by using by parts. So now this function, integral x in x dx, is also the same thing as in x all over x dx. Is that clear? So if you agree with me, without one telling you, you now compare with this integral. U is equal to in x, then the v is equal to x dx. Okay, we now see, let u be equal to in x and v be equal to, the v is equal to x dx. Now, look at this formula. You know very well that we have our ordinary u and ordinary v. Amen. And also we have in the integral, we have our ordinary v and du. How are we going to obtain our ordinary v and dv? Is for us to differentiate this function with respect to x and integrate this function with respect to x. We will obtain our du and also our v respectively. Is that clear? So now let us differentiate this function. If we differentiate this function with respect to x, our du all over dx is going to give us 1 all over x. Do you agree with me? Then our integrate this function both left and right with respect to x. We will have our v equals to x raised to the power of 2 all over 2. Is that clear? Okay. Okay, let's do it this way for the sake of manians. 1 plus 1 all over 1 plus 1, which is equals to x raised to the power of 2 all over 2. Do you agree with me? So at this point, we are going to substitute in these values, this into this formula. But we need du, not du all over dx. So what we need to do, we cross multiply. If we cross multiply, our du will now be equals to dx all over x. Is that clear? So now we have to substitute this and this into, and our v is equals to x squared all over 2. Then we have to substitute it into this formula by writing our integral, x in x, the x is equals to our ordinary u here is in x, amen, close bracket. Then our ordinary z is x squared all over 2, x squared all over 2, then minus integral, our ordinary v is x squared all over 2 times our du here is dx all over x. So our du here, look at it there, the x all over x. Then if you can see what I am saying, this and this will go. So this is equals to, we can rewrite this one this way, either x squared all over 2 in x minus integral. This and this cancel will give us x times the x all over 2. Then this is the same as x squared all over 2 in x, amen, minus, note that we have 1 all over 2 constant, then we factor it out, x dx. So if we integrate this, we are going to have x squared all over 2 in x minus 1 all over 2, integrate x dx will give you dot x plus, let's just the powers of 1 plus 1 all over 1 plus 1 plus a constant k, either k, p, or b. Is that clear? So if you agree with me, this is equals to x squared all over 2 in x minus 1 all over 2 times x raised to 1 plus 1 will give us what? 2 all over 2 plus k. Then, if you can see what I am saying, this one, we can multiply them. Is that clear? The numerator will multiply this numerator, this denominator will multiply this denominator. So if you agree with me, we have x squared all over 2 in x minus 1 times x squared will give us x squared all over 2 times 2 will give us 4 plus k. This is our final answer. Or, if you can see what I am saying, we know that we can still rewrite this answer in this form. Either x raised to the power of 2 all over 2, all in bracket, in x minus 1 all over 2, all in bracket, plus k. Either you go for this or you go for this. They are all the same. Thank you. Please subscribe to the channel, like and share to your friend. Thank you for watching.